Hi, it's Maren Vernon. I'm back today to talk to you about giving the computer instructions again, but this time we're going to be drawing geometric shapes. We're going to use a program that I've written again to practice, and maybe we're going to use a special tool called a Makey Makey to be able to code with food. Let's get started. Let's have a quick review. Computers really do four things. They receive input, they store information, they process information, and then they output something. An input could be typing on your keyboard, clicking with your mouse, using your voice to say commands, using your arms so that a motion sensing camera can understand maybe if your arms are down, one thing happens, and if your arms are another thing happens. Then the computer stores the information, processes it, and outputs something. For instance, I could say 2 plus 2 into my computer. It would store that, process it by adding those numbers together, and then it should output 4. In order to process that information correctly, the computer needs an algorithm. It needs a set of step-by-step instructions to follow. So when you are coding a computer program, you are writing one or more algorithms and breaking a big task down into smaller steps. If you haven't seen my previous video where we did this to fly an astronaut around to the different planets, check it out. Our big task today, however, is we're going to create something called turtle graphics. These are pictures created when a cursor, called the turtle, draws on a plane, like a piece of paper. Turtle graphics were named after a class of educational robots called turtles that were developed in the 1940s and could draw pictures. Here, I'm creating a turtle graphic with a modern-day turtle called the Gigglebot. You'll notice that we've pre-programmed this into a computer chip attached. We've given it instructions to draw a square. Excellent. The marker goes right inside so that it can record our steps on the whiteboard below. Here we've tried a bit of a spiral. Turtle graphics can also be used in other languages. For instance, turtle graphics were used first in a language called Logo. But here I have an example of it using Python. You'll see the Python code on the left, and on the right, you'll see the output. That little arrow is our turtle, and it's drawing on our screen different shapes. This is what we're going to try today. We're going to pair up with a Scratch program that I wrote so we can practice turtle drawing and make the graphics appear on our screen. I've programmed this project so that pressing certain keys makes something happen on the screen. For instance, pressing the right arrow makes the cat move forward. What we're going to do is write an algorithm, step-by-step instructions, and use these keys to draw shapes on our screen. On this Scratch project, we can use keyboard keys to tell our turtle, which in this case is the drawing of a cat, to draw lines on the screen. The first thing we need to do is think about how we would draw lines ourselves. If we're drawing lines with a pencil and a piece of paper, you can't just draw the lines in the air. The first thing you need to do is put the pencil on the paper. So the first thing we need to do here is to tell our computer to put the pen down. I'll press the down arrow.
Pen down.
Now that the pen is on the paper, I need to draw the first side of a shape. Let's make a square. In order to make a square, I'm first going to move forward.
Move forward.
Let's make it a little big. I'm going to try that 2 more times.
Move forward.
Excellent. Now I've drawn the first side of my square. Now I need to draw the second side of my square. But just like when I was coding with my astronaut, I have to remember that my character can only move in the direction that it's facing. I first have to change its direction. If I'm drawing a square, I need to think about the shape of the angles that I need to use. Let's look at these 3 angles: 90 degrees, 120 degrees, and 60 degrees. Which one looks like the shape of a square? For 90 degrees, I'm going to press the W key.
Turn 90 degrees.
Excellent. Now I need to move forward to draw my other side. Again, I'm going to press the forward arrow.
Move forward.
I did it 3 times last time, so I'll do it 3 times again.
Move forward. Move forward.
Okay, time to change direction again. The square has the same angles all the way around, so I'll press W for 90 degrees.
Turn 90 degrees. Move forward. Move forward. Move forward. Turn 90 degrees. Move forward. Move forward. Move forward.
Awesome! When you are pressing a key on the computer, you are closing a circuit and sending an electronic message to the computer that the key was touched. An electric circuit is a pathway over which electrons flow, and an electron is a very small piece of matter and energy. When the key isn't pressed, the circuit is open and energy isn't flowing. When the key is pressed, the circuit is closed and the energy flows, so the computer knows you pressed that key. Keyboard inputs are perfectly fine to use, but if we want to make it extra fun, we can actually use something called a Makey Makey, attached to fruits and vegetables that we can use as our keys instead of actual computer keys. What? Well, we're using a little bit of science. With the Makey Makey, the circuit isn't under the keyboard. It's really out in the open where we can connect with it. I've set up a Makey Makey on my desk. You'll see the Makey Makey here, attached with some alligator clips to various conductive materials. I've got a wooden board with some copper tape. I've got some metal bottle caps. I've got a piece of plastic covered with aluminum foil. I've got a pepper, and I've got some goo. I've also got this metallic object that's going to act as our earth. Let's test out our Makey Makey setup. I'm going to ask my assistant to first put her hand on earth. Now I'm going to ask her to try to close the circuit by touching the copper tape.
Hand color change.
Excellent. It seems to be working. Now that we know that this works, we're going to start our drawing project. As I mentioned, the first thing we need to do, whether we're drawing on paper or on the computer, is to put the pen down. Can you put the pen down?
Pen down.
Excellent. Our aluminum foil is penned down. Now we need to draw our first side. To go forward, we touch the bottle cap labeled right. Can you move this forward to draw our first side?
Move forward. Move forward.
Wonderful. When making a square, we now have to change direction because our character can only draw in the direction it's facing. Our pepper is 90 degrees. Our goo is 120 degrees. Assistant, what do you think we need for our angle to make a square?
I think we need the pepper since it is 90 degrees.
Excellent. Go ahead and touch earth and the pepper.
Turn 90 degrees.
Perfect. Do you want to change the pen color?
Pen color change.
Awesome. Okay, let's move us forward to draw our next side. Don't forget, you need to touch earth and the direction.
Move forward. Move forward.
Perfect. Let's change our angle again
Turn 90 degrees.
and draw the next side.
Move forward. Move forward.
Okay, let's bring us home and complete the square. One more direction change
Turn 90 degrees.
and draw our last side.
Move forward. Move forward.
Nicely done. Let's try drawing a triangle now. First, we're going to have to lift the pen. We're going to touch earth and touch the bottle cap with up.
And up.
Now we're going to move forward.
Move forward.
Whoops! Let's move backward.
Move backward.
And let's change our direction so that we're facing straight. Can we hit another 90-degree pepper?
Turn 90 degrees. Move forward. Move forward. Move forward.
Excellent
Move
job,
forward.
assistant. Okay, let's put our pen down and get ready to draw our next shape.
Pen down.
Do you want to change the pen color?
Yes.
Pen color change.
Excellent. Okay, let's create the first side of our triangle.
Move forward. Move forward.
Now, we chose 90 degrees for our square. What degree do you think we need for our triangle? 90 degrees or 120 degrees?
I think it's the goo because it's 120 degrees.
Let's give it a shot.
Turn 120 degrees.
Perfect. Can you draw our next side?
Move forward. Move forward.
Okay. You want to change the pen color?
Yes.
Pen color change.
And we got to change our direction.
Turn 120 degrees.
Awesome. Let's draw the last side.
Move forward. Move forward.
Excellent job, assistant. So using these conductive materials, we were actually able to replicate the keyboard keys. But instead of hitting W or S, we used pepper and goo. The Makey Makey isn't absolutely necessary for this practice, but it does make it a lot more fun. So if you can get your hands on one, go ahead and give it a shot. Hey, assistant, did you get any shocks or anything while touching these?
Mm-mm.
Exactly, because while these materials are conductive, they don't pass enough electricity to shock you, so it's totally safe to use. You just have to find conductive material. You could try Jell-O, pudding, water if you're really careful, but aluminum foil, metal objects, vegetables, goo, copper tape, these are all great to try. You could also hold one alligator clip and get your friend to hold the other. Then when you clap hands, you pass the electron through you into your friend, and suddenly you've closed the circuit again. I hope you've had fun today. Thank you for joining me.